Hello students, Namaskar. Today's topic in the chapter matrices is multiplication of matrices. Multiplication of matrices. Dear students, first we need to understand how can two matrices be multiplied, or whether two matrices can be multiplied or not, or for what condition two matrices can be multiplied. So here I am writing two matrices A and B can be multiplied or the product AB can be obtained if and only if the number of columns in A is equal to the number of rows in B. This condition, students, you need to keep always in your mind, that two matrices A and B can be multiplied. Means the product of A and B, AB, can be obtained only in one condition, that is the number of columns in the first matrix is equal to the number of rows in the second matrix. This is the condition required for the multiplication of two matrices. Okay, now we will be taking two matrices A and B such that the number of columns in the first matrix is equal to the number of rows in the second matrix. Suppose we get AB, that is the product of A and B. Here A is called the pre-multiplier and B is called the post-multiplier. So condition for the multiplication of two matrices is the number of columns in the pre-multiplier is equal to the number of rows in the post-multiplier. Okay, so we'll be taking two matrices such that the number of columns in the pre-multiplier is equal to the number of rows in the post-multiplier, and then we'll talk about how they will be multiplied. So I hope you have understood how two matrices can be multiplied. Now I am taking two matrices. Let A m by n, order of A I have taken m by n, and B with the elements Bij, and the order I am taking n by p. You may see I have taken the number of columns in the first matrix is equal to the number of rows in the second matrix, means both can be multiplied. So let A and B be two matrices then the product of A and B, that is AB, is a matrix of order m by p. Defined by AB of order m by p. Here if you want to write m by p, you may write, or AB is equal to, here I am writing AB Ij and m by p, where ABIJ is the sum of product of elements of ith row of A and the corresponding elements of jth columns of B. This statement you need to understand, students, properly. Here once again I am telling you this what I have written here just now. I have taken two matrices A and B. I took two matrices A and B such that the number of columns in the first matrix, that is A, is equal to the number of rows in the second matrix, because I am to multiply both of these, and the multiplication of these matrices is only possible for this condition. Okay, so I have taken these two matrices. Now the product or the multiplication of these two matrices is a matrix of what order? Of order the number of rows in the first matrix by the number of columns in the second matrix. So that is what I have written here. Then the product of A and B, that is AB, is a matrix of order m by p, defined by AB is equal to a matrix of order m by p. It is actually p. Okay, and the elements I have written ABIJ. Now what this element ABIJ, suppose I talk about A11, A12. What are these elements? How these elements will be obtained? So these elements will be obtained by this particular statement. See, read it carefully. ABIJ is the sum of the product of elements of ith row of A and the corresponding, or you can write with the corresponding elements of jth column of B. So now this is the definition of multiplication of matrices. This will be illustrated better with an example. Students, I am taking a matrix A whose order I am writing. Suppose I am writing a matrix first 2 3 4 1 2 3. The order of the matrix is 2 by 3. Here another matrix I am taking B, and it is 3 2 1 1 1 2, and the order of this matrix is 2 by 3. You can see this we will have to take of order. Since the number of columns in this is 3, therefore the number of rows in this matrix will have to take 3. So 1 1 1 2 1 2 3 1 3. I have taken this matrix of order 3 by 3. Okay. Now see, students, the number of columns in this matrix is 3 and the number of rows in this matrix is 3. Therefore it is possible to multiply both of these matrices, and the obtained matrix, the matrix AB, will be of order what? Will be of order 2 by 3. So here I am writing 2 by 3, and that is equal to how this matrix of order 2 by 3. 2 by 3 means 2 rows and 3 columns. So these 6 are the elements of this particular matrix. How these elements will be obtained is what we are going to talk about now. See, first of all, the element A11, or you can write it is AB11, it is AB12. How AB11 will be obtained? AB11 is the sum of the product of the first row of this and the first column with the elements of the first column of this one. So if I multiply the corresponding elements of first row and first column, 2 will be multiplied by 1, 3 will be multiplied by 2, and 4 will be multiplied by 3, and then all of these 3 will be added and first element of this one will be obtained. Okay, if I talk about this particular element A12, how this particular element will be obtained? This element will be obtained as this will be the sum of product of first row of A with the corresponding elements of second column of B. So this first row of A will be multiplied by this second column, means the corresponding elements of this will be multiplied by the corresponding elements of this column, and then they will be added, and that's how this element will be obtained. So this is how we'll be getting all of these. So talking about the this first element, that is AB11. How AB11 will be obtained? First row of this one, first row of this one, and first column of this one, and corresponding elements to be multiplied. 2 multiplied by 2 is equal to 2 plus, so here I am writing 2 plus 3 multiplied by 2, 6 plus 4 multiplied by 3, 12, and that's how it is 20 is the first element of this one. I can write here 20, the first element of AB. Now talking about AB12, it is suppose is AB12. So how AB12 will be obtained? The corresponding elements of first row of this will be multiplied by the corresponding elements of second column of this one. So multiply 2 multiplied by 1 plus 3 multiplied by 1 plus 4 multiplied by 1, and that is equal to 9. This element is A13, or you can say AB13. The first row of this particular matrix will be multiplied by the corresponding elements of third column of this one, and then they all will be added. So 2 multiplied by 1 is equal to 2 plus 3 multiplied by 2 is equal to 6 plus 4 multiplied by 3 is equal to 12. That's how this is also equal to 20. So I can write here 20. Now I hope you can do it ahead. See, this is element number A21, this is element number A22, or AB if you are writing by the AB21, AB22, and this is AB23. Okay, so to get this particular element, we'll be taking the second row of A and first column of B. So second row of A will be multiplied by the corresponding elements of second row of this one and first column of this one. So 2 multiplied by 1 is equal to 1 multiplied by 1 is equal to 1, 2 multiplied by 2 is equal to 4, and 3 multiplied by 3 is equal to 6, 9. So 9 plus 4 plus 1, 9, here I am writing, see, 1 multiplied by 1 is equal to 1 plus 2 multiplied by 2 is equal to 4, and 3 multiplied by 3 is equal to 9. So it has been 14, and 14 is this particular element. I hope you are understanding. Now to get this particular element, second row of this and second column of this one. So it is obvious that 1, 2 and 3, it is equal to 6. This will be multiplied by this one. So 1 plus 4 plus 9, 1 plus 4 plus 9. How it is obtained? This multiplied by this one plus 2 multiplied by 2 plus 3 multiplied by 3. So 9 plus 4 is equal to 13, and 1 14. So that is how we have found the product of these two matrices. I hope you have understood this particular statement also, and the example has illustrated this particular statement well. One more example if I take, very simple example I am taking, students. Suppose A I take as a column matrix 2 3 4, the order is 3 by 1, and here I take B, I take a matrix, a row matrix I will have to take 2 1 1. Dear students, order of this one is 1 by 3 and the order of this one is 3 by 1. So since this number of columns in this one is equal to the number of the rows in this one, therefore it is possible to get AB. Okay, and what will be the order of AB? The order of AB will be 3 by 3. 3 by 3. So since the order of AB is 3 by 3, so the elements will be, these are the 9 elements. If I talk about the first element here, that is AB 1 1, the first row of this will be multiplied by the first column of this one, corresponding elements will be multiplied and then added. Since there is only one element in the first row and one element in the first column, so 2 multiplied by 2 is equal to 4. And then first row multiplied by this 2, then first row multiplied by this one 2, and then second row with the first column, so 3 times 2 is equal to 6, 3 times 1 is equal to 3, 3 times 1 is equal to 3, and then 4 times 2 is equal to 8, 4 times 1 is equal to 4, and 4 times 1 is equal to 4. We have got a matrix of order 3 by 3, that is the product of these two matrices A and B, AB. Okay.